So guys, this is just a short video of how to do numbering conversions. So this is from unit 4. I know most of you guys don't know how to do these questions. So what I've done is that we're going to do a question from the past paper exam, and it's going to explain most of the concepts of how to do conversions. So now let's do conversions. So we're doing conversions. Now, every time when you come across questions that deal with conversions, numbering conversions, what you need to do first is this. So every time you come across a question, make sure that you make a table. Yeah. So now this table is going to help you a lot. So what you need to do is just draw this table every time you start. Before you start, just make the conversion. So here you put your number, and then you put your numbers in binary. Yeah. So now we're going to start with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So when you look at numbering conversions, in numbering conversions you have binary, octal, decimal, and hexadecimal. So now these numbering conversions have got bases. So you have base 2, binary is in base 2. So it is in base 2, octal is in base 8, decimal is in base 10, and hexadecimal is in base 16. So now these are the numbering conversions that we're going to talk about in cs110. Now you've seen these numbers that I've written here. These numbers range from 0 to 15. Now when you look at this, so from 10 to 15 numbers end. So when you start with 0 to 9 numbers, that's where they end. And then 10 is a combination of 1 and 0, 11 is a combination of two ones, 12 is a combination of 1 and 2. So now look at this. What you need to do first is convert all these numbers to binary. So now how do you do the conversion? So you start with let's say for example you have 2. So you have 2, that is your number that you are converting. Now you need to convert this 2 to what? To binary. Binary is in base 2, so you get the base and then you divide it throughout. 2 into 2 is 1, remainder what? 0. 2 into 1, it's 0, remainder 1. Now you have this, and then how are you going to write your numbers? So you write your numbers from the bottom to the top, just like in the Bible. It says that the first shall be last and the last shall be first. So what is 2 in binary? So 2 in binary is equal to 1, 0, base 2. So now let's finish this table. Yeah. So here you start with your 0, and then 1 is equal to 1, so 1 is equivalent to 1, and 2 is equivalent to 1, 0, 3 is equivalent to 1, 1, 4 is equivalent to 1, 0, 0, 5 is equivalent to 1, 0, 1, 6 is equivalent to 1, 1, 0, 7 is equivalent to 1, 1, 1, 8 is equivalent to 1, 0, 0, 0, 9 is equivalent to 1, 0, 0, 1, 10 is equivalent to 1, 0, 1, 0, 11 is equivalent to 1, 0, 1, 1, 12 is equivalent to 1, 1, 0, 0, 13 is equivalent to 1, 1, 0, 1, 14 is equivalent to 1, 1, 1, 0, and the last one is equivalent to 1, 1, 1, 1. So now these are your conversions. You've converted these numbers to what? To binary. So now when you look at 10 in hexadecimal, so hexadecimal is the only number that proceeds up to 15. So now when you reach 9, since numbers end from there, you start now using what? The alphabet. So you start with A, B, C, D, E, and F. So the last thing that you write on this table is F. So 15 is equivalent to F, 14 is equivalent to E, 13 is equivalent to D, C is equivalent to 12, 11 to B, and 10 to A. Now look at this, we have this question. So we're going to do some of the exam questions from 2025 past paper. So the question reads, Alice is a software developer working on a microcontroller project. She needs to configure hardware registers, which requires converting numbers between different bases. So we have decimal, binary, octo, and hexadecimal. The first question reads, so question A on this question 4, so we have 4A. It says the configuration register for a device requires the value 13. So now you have a value 13. What's its equivalent in? So we're going to start with binary. So what is 13 in binary? So you're going to do this. So 13, how do you convert that? Just do this. Since binary is what? Is base 2. So you're going to divide everything with 2. So you have 13. 2 into 13, you are going to have 6, remainder what? 1. 2 into 6, it's 3, remainder what? 0. 2 into 3, it's 1, remainder what? 1. 2 into 1, 0, remainder what? 1. Now you write your numbers from bottom to what? To top. So we're going to have 1, 1, 0, 1 in base 2. So that is your number in what? In binary. So when you come to this table, you're going to see that 13 is what? 1101. And that is your answer. Now let's go to the next question. So the second one says convert it to what? To octo. So you're going to convert this to octo. So to octo. Octo is in base 8. Now, how do you convert numbers to octo? So you have this binary. You're going to get this same binary number since we've already converted it. So we're going to have, so 13 is equal to 1101 in base 2. Now you have to convert it to what? To base 8. So now this is what you're going to do. So when you look at base 8, how many times can you multiply 2 to get 8? It's 3. So that means that in one octo number you have how many binary digits? You have 3 binary digits. So this is what you're going to do. So you write your number, which is 1101, and then you're going to be cutting it in 3. So you have 3 binary digits. Now you start from the right going to your left. So this is what you're going to do. So you have 1, 2, 3, and then you cut it from there. Yeah, so you're going to have 101 and 1. Now this is just simple mathematics and simple basic knowledge. When you add 2 zeros in front of a number, it changes nothing. When you add 2 zeros in front of a number, changes nothing. Since we said that one octo number has 3 binary digits, so when you write this one binary digit, it's not adding up, but it has to be what? 3 binary digits. So you are going to have now numbers that are 001 and 101. When you come to this table now, look at this table. You're going to look for numbers that have 101. What is 101? So 101 is on 5. So you're going to say 101 is equal to 5, and 001 is what? 1. Now when you look at this, you only have 1 here, right? So if you add 2 zeros in front of the number, it changes nothing. So you have that. So I'm going to add 2 zeros there, and then you have your number. So this is 5 and 1. Now how do you write your answer? So you're going to say 13 in binary is equal to what? 1, 5 base 8, and you're done. Yeah, okay. So let's go to the third one, which says convert this same number to what? To base 10. Now for you to convert it to base 10, so how are you going to do it? So you have base 10. What number are we converting? 13 to base what? 13 to base 10. So when you look at 13, it's already in base 10, but how are you going to convert it? So you use the face and position value concept. So you're going to have 13 there as your number. What is your position? 0 and 1. So the position values, the positions run from 0 to 1, from the right, the last number on your right, to the one on your left. So now you have 0 and 1. Let's convert that. So how do you convert? So you're going to get, now this is in base what? It's in base 10. So how are you going to convert it? So you do 10 to the power of the what? the position times the face, which is 3, plus 10 to the power 1, so it's base times position, so 10 to the power position times the face, so we are going to have 1. Yeah, so you have that 10 to the power 0 or 10 to the power 1 is what? 10 times 1, it's 10, plus 10 to the power 0 is 1. 1 times 3, you're going to have 3. 10 plus 3 is equal to what? 13. It's already in what? In base 10, and you're done with your question, done answering. Now let's convert this number to what? Let's convert it to hexadecimal. Yeah, let's convert it to hexadecimal. So how do you convert your numbers to hexadecimal? So you have 13. Yeah, so you have your 13 there. Then what you're going to do is this: you're just going to say 13 divided by 16. So 16 into 13 is what? 0 remainder what? 13. And then you're going to write your 13 there. 13 is just like that. And then when you come here, 13, only numbers that are in what? Hexadecimal range up to 15. So your 13 is equal to what? It's equivalent to D. So 13 is D in what? Base 16. But there's another way of answering this question. You get your binary numbers, yeah? So you get to binary numbers. What is your binary number? Our binary number is 1101 in base 2. When you come here, which one is equivalent to that? It's still 13, which is 1101, and you get 13 there, and 13 is equal to what? To D. So your answer is D in base what? In base 16, and you're done with that question. Yeah, so now we go to another question. Question 2 reads, so another register, so this is 4B, question 4B from the exam. This question reads, another register uses the value, so our value is 1 0 1 1 0 1 in base 2. So another register uses the value, write its equivalent in binary. So you're going to start with converting it to binary. This is already a binary number, so there's no need to convert. You leave it just like that. Now, so that is our one. How do you convert now this to what? To octo. So if you remember, we said that one binary number, one octo number has got how many binary digits? 3. So you have that, and then you're going to have your number, which is 101 101, and then you are going to cut it 1 2 3, count it, and then cut it in half. When you go to the table, when you look at this table that you made here, 101 is what? It's 5. So 101 is equal to 5, so you have 5 and 5. How do you write your answer? So it's going to be 5 5 base what? Base 8, and you're done answering your question. So when you make that conversion table, it's going to be easy for you. Yeah, and then you come here, so you have 12, question 3, your third question there. So now it says convert it to what? To decimal. So how do you convert this to decimal? So you have your number, which is 101 101. You put the position and face value concept. So you're going to have 0 1 2, those are positions, 2 3 4 and 5. Yeah, so now you start with the position and position value and face value concept. So you start with the 1. So this is in base 2, so you're going to be using 2. So 2 to the power of the position, which is 0, times the face, which is 1, plus 2 to the power 1 times the face, which is what? 0, plus 2 to the power 2 times 1, plus 2 power 3 times 1, plus 2 to the power 4 times 0, plus 2 to the power 5 times 1, just like that. So you're going to start from, you can start from either way. So you have to convert. So 2 to the power 5, so 2 to the power 5 is 32, plus 2 to the power 4, this is 16, 16 times 0, it's 0, plus 2 to the power 3 is 8. 8 times 1 is 8. 2 to the power 2 it's 4. 4 times 2 is 4. 4 plus 2 to the power 1 it's 2 times 0, it's going to give you 0, plus 2 to the power 0 it's 1. 1 times 1 is 1. So it's 2 plus 8 it's 40. 40 plus 4 44, plus 1 45. So you're going to have your 45 there in what, in base 10 as a decimal, what, as a decimal number. So that's how you do it. Yeah, and then you have now converting it to what, to hexadecimal. So how are you going to convert this number to hexadecimal? So you can get the binary number, which is there 101,101. Now hexadecimal is in base 16. Yeah, so now how many times can you multiply 2 to get what, 16? So you're going to multiply it 4 times. That means that in one hexadecimal number we have 4 binary what, binary digits. So now this is what you're going to do. So you have 4 binary digits. Now you have these numbers here, so you're going to count, going to cut it in 4. So you start from the right going to your left. So you start 1 2 3 4, and then you're going to cut it here. Yeah, and then you have 2 numbers here remaining, and we said that one hexadecimal number has 4 binary digits. So you're just going to add 2 more what, 2 more zeros. When you come this side, you find that there are these numbers that have what, only 3 binary and what. So you're just going to add more zeros just to make them 4. Just add some zeros in front, it changes nothing. So when you add some zeros, it's going to change nothing. Just put those zeros there and you're done. Now look at this, you have 1101. So what is 1101? So you come here, 1101 is 13, and 13 is equal to what, to D. So you're going to have D there, and then you have this 0100. What is 0100? It's here, 0100, which is 2. So it's going to be equal to 2. So how do you write your answer? So you're going to say 2D plus what, plus 16, and you're done with that question. Okay, so now we have question C here, question C, which writes as 3F. So now they say 3F converted to binary first. So you are starting with binary. So 3F in binary, you go back to your table, just go back to this table now. You have that table you're used to making it. So you have 3. What is 3 in hexadecimal? So it's what, 0 0 1 1. And then F is 1 1 1 1, 4 ones, and 1 1 1 1 in base 2, and you are done. So you see the importance of making that convergence table. It will help you, very easy to answer some of these questions. And then you have to convert it to octo. So you've seen this, we've already converted this binary number to octo, yeah, to this hexadecimal number to binary. So octo will be simple, just get this same binary number, which is how many ones, 1 2 3 4 5 6, 1 2 3 4 5 6, and then just cut it there. Yeah, cut it. You have this is 7 7. So now your answer is 7 7 in base what, in base 8, and you are done. Simple. If you want, you can add those 2 zeros, they are going to change nothing there. So you have that, and you have to convert it to decimal, a decimal number. So you have, which is 1 2 3, convert this to a decimal number. So you have 3 and F. Now when you look at the position and face value concept, you have 0 and 1. So this is already, it's in base 16. So what are you going to do? Base times the position, so base to the power of the position, times the face, which is F, plus base power of the position times the base. And then 16 to the power 0, it's 1. 1 times F, and then F is what? F is 15. So you're going to do 1 times 15, it's 15, yeah? Plus 16 to the power 1 is 16. 16 times 3, so you're going to do 16 times 3. 3 times 6 is 18. 8 remain 1. 3 times 3, 3 times 1 is 3, plus 1, 4. So you have your answer as 40 what? 48. So you're going to do 48 plus 15, 5 plus 8, it's 13, 3 remainder 1, 1 plus 4 is 5, 5 plus 1, 6. So you have your answer as 63 in base 10. That's how you do it. You converted it to what? To decimal. Now you have to convert it to what? To hexadecimal. Hexadecimal is base 16. It's already in base 16, so you just copy the same number, put it there, and put the base, and you are done. Yeah, that's how you convert. That's how you do the numbering conversions. Now let's do our last question. So the last question says, okay, so the last question says that convert, so the debugging purposes, so for debugging purposes, Alice is given the number 57. So this is 4D. Yeah, this is question 4D 1. So Alice is given 57 base 8. So write its equivalent in binary. So 57 is in binary. We have 57, which is in binary. 57, oh yeah, it's not in binary, it's in octo actually. It's in octo base 8. Yeah, so now you have to convert it to what? To binary. So the first one is binary. First one is binary. Now look at this conversions table. You have 5 and 7. So when you look at 5, look at 5. 5 is what? 101. So 5 is equal to 101, and then 7 is equal to what? 111. So you just put these two together, saying 101 111 in base 2, and you're done with binary. So this conversions table, please make it every time you're starting. Just make it. And then you have what? You have to convert it to octo. It's already in octo, so you're just going to say 57 base 8, and you're done. So that is for 2. And then you have to convert it to decimal, a decimal number. So you're going to say 57 position concept 01. It's in base 8, so you're going to say 8 to the power 0 times the face, which is 7, plus 8 to the power 1 times 5. Here you do 8, that is 1 times 7, it's 7, plus 8 times 5. 8 times 5 is 40, so you're going to do 40. So your answer is what? 47 in what? In base 10, and you are done. That's how you do it. Is it? Yeah. That's how you do it, and you're done. So now convert it to hexadecimal, the last one. So how do you convert it to hexadecimal? Now this is what you do. So hexadecimal, you already have this binary number, which is 101 111. Yeah, so you're going to count 1 2 3 4, cut it there, 0 1 0 0. Yeah, and then you're going to have, this is F and this is 2, so you're going to say 2F base 16, and you're done. When you look at the conversions table, F is equal to this and 2 that, and you're done. That's how you do it. And that marks the end of this video. I hope you've learned a thing or two.